Hello, today I'll be going over imaginary and complex numbers. The objectives of today is to learn what I is, learn the cycle of the powers of I, learn the standard form of complex numbers, and learn how to add, multiply, subtract, and divide complex numbers. So let's get right to it. So let's take the quadratic x squared plus 1 is equal to 0. So your roots are just going to be plus or minus root of negative 1. But for centuries, people are puzzled about what the root of negative 1 is. And in the end, it was termed with I. So I is equal to the square root of negative 1. So let's see the powers of I. I to the power of 1 is just going to be I. I to the power of 2 is going to be the square root of negative 1 squared, which is negative 1. Let me box these answers. I to the power of 3 is equal to I squared times I, which is equal to negative 1 times I, which is equal to negative I. I to the power of 4 is equal to I to the power of 3 times I, which is equal to negative I times I, which is equal to negative I squared, which is equal to negative 1 times negative 1, which is equal to 1. I to the power of 5 is just going to be I to the power of 4 times I, which is 1 times I, which is just I. I to the power of 6 is equal to I to the power of 5 times I, which is equal to I times I, which is equal to the square root of negative 1 squared, which is equal to negative 1. So we're starting to notice a pattern here. I to the power of 1 matches with I to the power of 5. I to the power of 2 is the same as I to the power of 6. So I think it's safe to assume that I to the power of 3 is going to be the same as I to the power of 7. Let's test that out. To the power of 7 is equal to I to the power of 6 times I, which is equal to negative 1 times I, which is equal to negative I. And sure enough, I to the I cubed is equal to negative I as well. And so we can also say that I to the power of 8 is equal to 1 because I to the power of 4 is equal to 1. So the powers of I cycle with every 4 powers. So the cycle is I, negative 1, negative I, and then 1. And then it cycles on with the same 4 numbers. Complex numbers are the sum of a real and imaginary number. The standard form of a complex number is a plus bi, where a is the real part and b is the coefficient of the imaginary part. So adding complex numbers, what you do is that you group the like terms. What I mean by like is you group the 2 real terms and then you group the 2 imaginary terms. Let's do that. You get 3 plus 2 plus 5i plus 4i. And what you get from this is 5 plus 9i. And that's your answer. When you're subtracting complex numbers, it's like adding the negative of this complex number. So let's do that. 2 minus 4i plus negative of 3 plus 2i, which is just 2 minus 4i minus 3 minus 2i, which is just negative 1 minus 6i. And that's your answer. So now let's multiply complex numbers. You get 2 plus 5i times 6 plus 4i. What you do is you basically expand it out. So let's do that. 2 times 6 plus 2 times 4i plus 5i times 6 plus 5i times 4i. Let's simplify that. 12 plus 8i plus 30i plus 20i squared. And I squared is equal to negative 1. So it's just 12 plus 8i plus 30i minus 20, which is just minus 8 plus 38i. And that's your answer. Dividing complex numbers is a bit harder, but you can use similar techniques. So first of all, we need to know what the conjugate of a complex number a plus bi is. The conjugate is just a minus bi. And the reason the conjugate is so useful is because when you multiply a plus bi times a minus bi, you get a real number, a squared plus b squared. And that's really helpful because you can't have an imaginary number in the denominator when you're dividing 2 complex numbers. So we can fix that by multiplying both the numerator and the denominator by the conjugate of this complex number 9 plus 2i. So So let's do that. Notice that I'm multiplying both the numerator and the denominator by the conjugate. When you do that, these two cancel out to be 1, so it doesn't really change it. So the bottom is equal to 9 plus 2i times 9 minus 2i, which is equal to 81 minus 18i plus 18i minus 4i squared, which is just going to be 81 plus 4, which is 85. So the denominator is going to be equal to 85. The numerator is a bit more complicated, times minus 2i. So you got 63 minus 14i plus 27i minus 6i squared. And what you get from that is 63 plus 6, because this is negative 1. So 63, so you get 63 plus 6 plus 13i. So you get 69 plus 13i. So your result is 69 plus 13i over 85. But this is not your final answer, because you have to split the 85 to both the 69 and the 13i. So you get 69 over 85 plus 13 over 85i. And this is your final answer. Thank you.